Hey, hi everyone. Good morning. So I think I'm audible and visible to all of you. Yep, everyone. Okay, fine, guys. So I think we can start. We all have joined the class. So okay, so hi Kamran, Deepak, Rahul, Shivan, Ganesh, Aditya, everyone. So let me share my screen and so that we can start with the class. Fine, guys. So in my last class, so basically I was talking about SVM, a support vector machine, and in this class, so I'm going to talk about basically algorithm called as logistic regression. So basically, it's not a regression algorithm, by the way, as its name suggests. It's a classification algorithm, so where you will be able to do a classification for a binary data as well as you will be able to do a classification for a multi-class. So whether it's a two class or maybe a multiple classes, obviously you will be able to build a model, and eventually you all will be able to do the classification. So in today's class, I'll be talking about a couple of algorithms. So maybe I'll be talking about a logistic, and then I'll be talking about a decision tree, a random forest, and if time suggests, then obviously I'll be talking about even a k nearest neighbor. So all this algorithm, and then agenda for tomorrow is to do a back-to-back practical for all of these algorithms that we have discussed, and that we are going to discuss today, and that we have discussed in my previous class, which was Sunday's class, and where I was talking about a support vector machine. I have given you the full derivation of the support vector machine, and with respect to that, so we'll do the practical. So one like a binary class classification, so one versus one, or maybe like a multi-class classification. So altogether, for all of this algorithm, we will be able to do a practical, and then we can build a small application, like a Streamlit kind of application. So let's get started, guys. So I believe classification is not a new problem for us. So we all know what happens inside the classification, and obviously we are talking about a supervised machine learning concept. It simply means that basically let me switch on my mobile so that I can see all of your chat in my mobile device. Yeah. So are we ready, guys? Every one of us? Yes. Ping me in the chat, please. Yeah, go ahead. Fine. So here, let's talk about a logistic regression first. So how logistic regression actually works, what is the mathematics behind a logistic regression? And it's not very tough. It's easier than I would say like a SVM that we have already discussed. Because in SVM, so we have done a lot, but yeah. So here you don't have to worry about much. But again, so there is a similar kind of a concept called as loss, and there will be a hyperparameter so which we have to train or maybe we have to tune. So every algorithm almost follow the similar kind of approaches. I'll not say 100% algorithm, but yeah. So some of the algorithm you are going to encounter, so where approaches is going to be different, it's not going to be same, but yeah. So if I'll talk about logistic, it follows the almost same kind of approach. So let me talk about a logistic, Logistic, logistic regression. As I said, so don't go after its name, regression. So it's not a regression algorithm, it's a classification algorithm that we are going to talk about it. So here, how logistic regression works. So the major function for this logistic regression is basically something called as sigmoid. So here, if I'm going to define a sigmoid, so sigmoid says that, let's suppose this is the sigmoid function. So 1 by 1 plus e to the power minus of z. So this is basically called as sigmoid function. So sigmoid, sigmoid function. So now this is the core concept, or this is the core mathematics behind a logistic regression, I would say. Now how this comes into a picture, we'll be talking about it basically. So here we have already gone through, and again, so if I'll talk about a sigmoid function, so sigmoid function, if you are going to draw a graph, you will be able to find out that sigmoid function is always going to give you an output in between 0 to 1. Doesn't matter what kind of an input you are going to pass, but yeah, this is how this graph look like. So it is going to give you, doesn't matter you are going to pass anything to anything, means minus infinity to positive infinity. If you are going to pass, it will always give you an output in between 0 to 1. This graph is like a little bit different, but yeah, so it's almost going to give you this kind of a graph. This is something called as sigmoid. So this function is always going to give you something between 0 to 1, not beyond 1 and not below 0. This is something that it will give you. Now, so how logistic function technically works? So as we all know that like a purpose of any algorithm that we are trying to learn into a machine learning is to do some sort of a prediction, or maybe try to find out some sort of a values. Now, if I'll talk about a classification, so classification simply means that it should give me a classes, right? It should give me a prediction that this particular things or this particular input belongs to class A, B, C, D or E, F, something like that, right? It is supposed to give it to me. Now, how this logistic regression comes into a picture? So what people have suggested that let's suppose there is a line, maybe y is equals to mx plus c, right? There is a line in 2D plane if I'll talk about, and we are able to, or just by looking into our data, so we can try to draw a line. Now, what if we can try to find out a probability, that what is the probability of an object which can be on this side of the line, or maybe which can be on this side of the line. So if I will be able to find out a probability, so maybe I will be able to do a classification, because we are already aware about y is equal to x plus c. So for whatever input, right, it is going to give me an output. It is going to give me output. So if I'm going to pass x over here, so obviously it is going to give me y. Now people have suggested that what if we can try to use some sort of a probability function over here, so which is going to tell me, and which could help me out in terms of finding out a position of an object on this side of the line, or maybe this side of the line. And this is where the sigmoid function comes into a picture. As we know that probability will always varies in between 0 to 1, right? This is what probability does. So probability will always try to vary between 0 to 1. So what we are trying to do is, so we are just trying to pass our data of the line, which is z. So z is nothing but it's basically y I'm talking about, right? It's basically y I'm talking about. So what if we can try to pass a line over here, and it will help me out to find out the probability of occurrence of a data, because data is going to be x, right? So probability of occurrence of the data on this side of the line, or maybe that side of the line. This is like a simple intuition that people have built, and based on that, so they have found basically an algorithm called as logistic regression. So that's the reason. So somewhere regression words comes into a picture, because we are trying to use a regressive line over here, and we are trying to predict, or we are trying to find out the probability that this object will be on that side of the line, or maybe this side of the line in 2D. If I'll talk about maybe like a ND basically, so over there obviously we'll be having a plane. So as a number of dimension of the data will keep on increasing, so obviously the dimension of this plane will keep on increasing. So line will become a plane eventually. Now, so here, if I'm going to rewrite this entire sigmoid function once again, so maybe I can try to rewrite in this way, e to the power minus of maybe mx plus c, right? Minus of mx plus c. So this z which I was talking about, so z was nothing but this particular line which I was talking about, and this is going to give you an output in between 0 to 1. It will never go below 0 or it will never cross beyond 1, and this is what even probabilistic function is going to do. And they have built the intuition that okay, so if probability is greater than equal to 0.5, right? So if the value of this value of sigmoid is going to be greater than or equal to 0.5, then in that case the class which I can try to define is equals to class 1. And if this is lesser than 0.5, then class which I can try to define is equals to 0. So I'm just talking about as of now binary class classification. So where we have two classes. So one class is basically like a 0 class and one class is basically a 1 class. So they said that if we have two class, for example, let's suppose we have a class 1 and class 0. It could be A, it could be B, it could be X, it could be Y, right? Depends on the intuition that we are going to perform. So here they said that let's suppose we have two classes 1 and 0, right? So if probability is greater than equal to 0.5, so in that case it is going to be class 1, and if probability is lesser than 0.5, in that case it is going to be class 0. Now, so this till this particular part things are completely fine, but we would be interested in terms of knowing that how it is going to learn, right? How it is going to learn, because this is the equation and obviously this is going to give me a probability. That's completely fine based on the line that we are going to draw. But how it is going to learn, how it is going to adjust the parameter M and C, because it is supposed to adjust the line, right? Or it is supposed to adjust a probability. If it is not able to adjust the probability, then there will be no learning. And if there is no learning, so obviously it will not be able to adopt the variation inside my data set. Now, so this is where the cost function, or I can say a loss function, comes into a picture. So which says that okay, so maybe you can try to find out a loss, or maybe you can try to find out a cost as per this particular loss function or cost function, and then you can try to adjust the parameter. For example, in case of a logistics, in case of a linear regression, so we were having a root mean square or mean squared error, right? And based on the mean squared error, so we were trying to adjust the parameter. Again, so in case of SVM, so we have seen a Lagrangian, basically Lagrangian equation, so which was helping me to adjust the weight. So in the similar manner, so here there must be some cost function, so which is going to help me out in terms of adjusting the parameter. Now, what is that cost function? And it looks a little bit like a, I would say, a complex when you will see the cost function, but believe me, it's very much logical. So here there is something called as people have adopted a log loss, or you can say another word, it's called as cross-entropy loss. So there is a loss function. So loss is nothing but a difference between expected and the predicted one. This is something called as loss, right? In a layman way, so loss is nothing but a difference between predicted and the expected one. So here there is something called as log loss that people have considered, or you can say in other word, cross-entropy loss. Now, what is a meaning of this log loss, or how this log loss or cross-entropy loss works? So like I said, that in case of linear regression, so we were talking about a mean squared error. Now here, so we are trying to talk about basically a log loss or the cross-entropy loss, a difference between like a expected and the predicted one, right? Predicted one. Now here, so this function says that loss function says that it is going to be 1 by minus of 1 by m summation of I is equals to 1 till m. So m is nothing but a number of data, obviously, or you can say even n or m, that's completely fine. There is no issue at all. And then inside a bracket, there is a very lengthy function, a long function, which you can try to write. But believe me, even this function we can try to derive. I'm not going to do it, but derivation, if you would like to derive this function, it is actually possible to derive this entire particular function. So here it says that y into log, as its name says, it's a log loss, right? So log of basically, here you can say h of 0. I'll tell you. So what is basically this h of 0 for a particular x plus 1 minus y. I'm just trying to make it a little bit simple. So 1 minus h of 0 of x. Now, so what is this y, by the way? So y is nothing but the actual value. The actual outcome. So let's suppose I was expecting class 1. So obviously this class 1 is going to be my y, means expected value, obviously the actual value. Yeah. Now if I'll talk about this h of 0 of x, so if we are going to pass x data, input data, so it is going to give me a prediction. Maybe I can try to denote it as a y hat just for the simplicity, right? Just for the simplicity. So it's called as basically a predicted value. So you can say this as a predicted probability. So again, value will be class, but yeah, probability, right? So if probability is more than like a 0.5, as I have mentioned, in that case, obviously it will belongs to one class. Otherwise, it will belongs to the other classes. Just for your reference and simplicity, I have written y hat. Technically, it's a probability which I'm talking about. So it will be a fraction number. It will not be an absolute one, right? It will not be the absolute classes, but just for your understanding, I have mentioned this particular part. I'm making this like a sense, I believe, right? And y is nothing but it's a actual class, maybe one class or maybe the other classes. And here, so if I'll talk about m, so m is nothing but number of training data. Okay. So this is the loss function that we are going to technically use. So the expected value log of the predicted one plus predicted probability plus 1 minus the expected one into log of 1 minus the predicted one. So it's very simple, right? It's very simple. So in multiple places, people have like just made it like a little bit tough, little bit hard in terms of understanding or in terms of even writing the equation. But yeah, like I said, it's not that difficult, and even we can try to derive this entire equation from the very scratch. That's also like a 3-4 line of a step, not more than that. So here minus of 1 by m summation of y log of predicted plus 1 minus y log of 1 minus predicted. That's it, right? So here the actual everywhere. So here we have y and here 1 minus y we have. Simple. Now, so whenever we are going to go for the training, right? Whenever we are going to go for the training, so obviously what we try to do. So we try to adjust something, right? We try to adjust the parameter. So in case of our equation, so if I'll talk about maybe this sigmoid function, so it's nothing but 1 by 1 plus e to the power minus of mx plus c. So here we'll try to train this m and c parameter, right? This is the only trainable parameter that I'm able to see, so that it will be able to adjust the lines, and eventually it will be able to find out the probability. So like on this side or maybe on this side of the line, depends, right? On this side or maybe on this side of the line, it will be able to find out the probability. Now, so we know the equation, right? We know the equation, the actual equation. We know the loss function, right? We know the loss function. So what we are supposed to adjust? So at the end of the day, we are supposed to find out a new value of m, right? And new value of c. This is what we do, right? This is what we do at the time of training. So new value of m is nothing but old value of m into eta, and then loss function with respect to m, and then c old eta loss function by c. I believe this equation number 1 and this equation number 2 is not at all a new equation for us, right? It's not at all a new equation for us. We all are aware about these two equations, and we all know that if I know about a loss function, I just have to do one thing. So I just have to like find the derivative of it, and with respect to m and with respect to c, and eventually I will be able to find out the new value of m and new value of c. Eta is nothing but a learning rate. We are already aware about it, right? A learning rate. I believe even I told you that what should be the standard learning rate with which you are supposed to practice at any point of a time. So maybe a 0.1, 0.01, such kind of a values you are supposed to try this out. And this is the hyperparameter. So you can try to train it, you can try to tune it. So this is the equation, so which is going to help me out in terms of learning. Now we know the loss function, right? We know the loss function. So maybe we can try to find out, right? Maybe we can try to find out this loss function with respect to derivative of loss function with respect to m, and we can try to find out a derivative of loss function with respect to the c, as simple as that. And then once we will be able to find out that, try to compute the values, keep on adjusting the value of m, keep on adjusting the value of c, unless and until, right? Unless and until this entire log loss or this entire error, or you can say cross entropy loss, will tend towards a 0, or it will stop changing, right? Or it will stop changing. And this is something called as gradient descent. So we keep on finding the gradients, we keep on evaluating this gradient unless and until we are not able to reach out to the minima or maybe a maxima. So where our loss will stop changing. So once my loss will stop changing, bingo, I'll stop the training. Making sense, guys? Yes? Making sense to all of us? Yeah, people are pinging me Bharti 0.1, 0.01, 0.001. Yeah, so these are the things, these are the learning rate with which you are supposed to try. So like I said, guys, it's not very different, I would say, right? It's not very different. So we have seen starting from a linear regression, then a SVM, and then this equation that we are talking about. Almost all these three is following the similar kind of a trend, a similar kind of a approach. The only thing is its core equation is getting changed. Yeah, its core equation is getting changed. And again, so here I'm not talking about something very different. So again, I'm just talking about the line, right? But what I'm saying is that, okay, this side of the line or this side of the line. So I'm just trying to draw the line, but this time let's try to find out the probability that, okay, so my data will be on that side or maybe my data will be on this side. I'm talking about a binary class classification over here. So where we have only two classes, right? Where we have only two classes. So I'm talking about such kind of an event. I'm talking about such kind of a situation. That's it. Fine. So Gala is saying just here to add the probability. Deepak is saying it's quite same as the previous algorithm, sir. Exactly. Exactly. Right? It's not very tough. At the end of the day, I believe we all know what is a meaning of a learning. Learning means adjusting the parameter. So what parameter we are trying to adjust? Obviously, we are trying to adjust m and c with respect to what we are trying to adjust with respect to the loss function. What is the loss function? A difference between, in a layman way again, right? In a layman way. So difference between your expected value and the predicted value. That's it. Yep. So not very different thing I'm trying to talk over here. I'm trying to talk about over here. It's a very, very easy function. And if you have to explain to someone else, maybe today, tomorrow, in future, you will be able to explain it to anyone, I believe, right? You will be able to explain it to anyone at any point of a time, right, guys? I believe you will be able to explain. Yep. Yeah. Okay. Now, so here I was talking about basically a binary class, right? Let's suppose we have two classes. Let's suppose we have A, B, or maybe true, false, maybe 0, 1 kind of a classes. Now, what if, right? What if our class are multiple? Maybe I'm talking about a 10 class starting from 0 to 9, maybe A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, right? Maybe X, Y, G kind of a classes. So what if I have a multiple classes? What if I don't have just a binary classes? So in that case, what I will do, guys? Yes. Yeah. So in that case, what I will do? So what if, guys, if we have not just a binary class, maybe a 0 and 1. So what if I have a multi-class? So what if I'm trying to use a logistic regression, but to solve a multi-class classification problem, not a binary class classification problem? So in that case, what we are supposed to change? Okay, Akshay is saying no idea. And I believe almost all of you. So, okay, Deepak is saying dimensionality reduction. But no, Deepak, if I'm going to do a dimensionality reduction, it is going to reduce the number of features. See, Deepak ji, why you are forgetting the original concept? What is the meaning of dimensionality reduction? Dimensionality reduction is nothing to do with your number of levels, right? So x1, x2, x3, x4, and then this is the y. So let's suppose we have 0, 1, 2, 4, 5, 8, or maybe instead of writing this, I can write maybe A, B, C, D, E. So dimensionality reduction is going to reduce the number of features, right? And it is going to basically showcase the variance of the feature maybe into the contracted or maybe like a feature that you are trying to reduce. So it is going to reduce the number of feature, but not the classes, right? Classes is going to be as it is. What if we have y as A, B, C, D, E? So maybe we have 5 classes over there. Yeah. So dimensionality reduction is not going to work, by the way. Dimensionality reduction is not even part of the talk as of now. Then we can't use logistic regression, sir, as it's only for a binary class classification. No, we can use it actually. We can actually use it, right? We can even use SVM. So even in SVM, so there can be a binary class classification problem that you can solve, and even you can try to solve a multi-class classification problem. And generally, people are going to ask you a question in an interview that will you be able to solve a multi-class classification problem with the help of logistic regression or with the help of support vector machine or support vector classification, SVC or SVM? I will simply say, yes, I will be able to do it. There is something called as 1 versus 1, 1 versus 1, OVO, right? OVO. Now, as of now, the equation that we are talking about is technically 1 versus 1 that we are talking about. Very simple, right? There is something called as OVR, 1 versus rest. Now, this is just a theoretical concept, right? OVR. But what goes behind? Because at the end of the day, we are talking about an algorithm. It simply means that there must be some sort of a mathematical intuition, right? I mean, like OVR, OVO is like just a word, just a term. But technically, there must be some sort of a mathematical equation, so which is supposed to give a backup. So OVO is nothing but this is something that we are talking about, that if we have like a 2 classes, so obviously OVO 1 versus 1, and it will be able to do the prediction. Now what is this OVR, by the way? So basically the equation that I'm trying to use over here, so as of now this equation is basically what? This equation is basically a sigmoid equation, right? This equation is basically a sigmoid equation. Now instead of using that, what I will do is, so there is something called as Softmax. So wherever, and even I'm going to use this Softmax function a lot of times in your deep learning classes, even in your computer vision classes, I'm going to use, and even in your NLP classes, a lot of time I'm going to use this Softmax function. So basically we can try to use a Softmax function. So wherever we have to find out a probability of one class, where we have like 10 of the classes. Let's suppose we have a class A, B, C, D, E, F, G, H, and so on, right? Now we have to find out that what is the probability of occurrence of this particular class amongst all the other classes. For example, we are trying to build maybe a computer vision model. So which is supposed to identify that whether I am wearing a black color shirt or maybe yellow color, maybe blue color, maybe red color, or maybe a green color. So what it will do is will try to give the probability of black, probability of red, a probability of yellow, and the final answer is going to be the one which will be having highest probability, and combined probability obviously is going to be 1, right? So there is a function called as Softmax function which I will be using over here instead of using a sigmoid. So instead of using a sigmoid, I will be using basically a Softmax function over there, and with the help of a Softmax function, so I will be able to do the exact same thing. Making sense to everyone, guys? Yep. Making sense to all of us? Yeah. Softmax function. So now what is the Softmax function, by the way? So Softmax function says that for any input x, right? Softmax function says that it will be e to the power x divided by summation of I is equals to 1 till n e to the power basically x. Simple. This is the Softmax function. Means, so this is basically the exponent, right? Exponent to the power input divided by all the input. Simple. So for this particular input, you will be able to, or for this particular class, you will be able to get the final values. And again, so your Softmax function is going to fluctuate between 0 to 1, and even your sigmoid function is going to fluctuate between 0 to 1. But yeah, Softmax function, so we are supposed to use, for example, so if I'm going to like give you this one, so maybe you can even try to like prove it. So let's suppose I have a data like 1.3, 5.1, maybe 2.2, maybe 0.7, and then 1.1. And then if you are going to pass this data, right? So e to the power x divided by summation of e to the power x. So now if I'm going to tell you that give me the probability for 1.3, 5.1, and then 2.2, 0.7, 1.1. So anyone guys who can give me the probability of all of this by using this function? Yeah. So simple. If I'm trying to find out the probability of 1.3. So what will be this equation? So e to the power x 1.3 divided by summation of e to the power 1.3 plus 5.1 plus 2.2 plus 0.7 plus 1.1. So it is going to give me a probability of this with respect to all, right? Then for 5.1, so e to the power 5.1 divided by same summation. Probability for this, so e to the power 2.2 divided by all of this, means it's called as 1 versus rest. This is called as basically 1 versus rest. So I'm trying to find out the probability of 1 with respect to all, right? Then for this with respect to all, then for this with respect to all, then for this with respect to all, and then for this with respect to all. So anyone guys who can give me a probability of 1.3? Quick calculation guys, quick. Your denominator is going to be anyhow same, right? Denominator is going to be anyhow same. Now give me this probability for 1.3. So denominator is going to be e to the power 1.3 plus e to the power 5.1 plus e to the power 2.2 plus e to the power 0.7 plus e to the power 1.1. Now denominator will keep on changing. So for this 1. E to the power 1/3, then 5.1, then 2.2, and so on. Give me guys probability. Give me quick. Yeah. Do the math. Open up your calculator quickly. Calculate it. So this is basically called as OVR, 1 versus rest, means we are trying to find out the probability of 1 with respect to others. And then same thing we are doing for the next one, same thing we are doing for the next one, and so on, right? So Deepak is saying for 1.3, so guys, you can cross check 0.02, and then for 5.1, 0.90, then for 2.2, he is saying 0.40, and then for like a 0.7 he is saying 0.01, and then like I'm not taking the change after that, 2 decimal point, and for 1.1 it's a 0.1, right? Who is having the highest probability guys out of this one? Who is having the highest probability? So can I say that the highest probability is having 5.1, and obviously I can see just in terms of even numbers that it's contributing more, right? It's contributing more. 5.1 is a biggest number, right? If I'll try to talk about 5.1 with respect to this, and if I'm going to ask you a question that what is the percentage of contribution of 5.1, if you are going to do the summation, obviously it's contributing 90%, right? So basically it's a, let's suppose if I'm trying to represent this one in terms of a class, again I'll be able to talk about the exact same thing. So instead of using, right, instead of using basically like a sigmoid function for a binary classes, OBO, right? So we can try to use maybe a Softmax function if we have a multi-class classification. Same thing happens even with respect to the support vector machine in terms of classification, and same thing happens even with respect to the logistic regression. So if someone is going to ask you a question that what is the function, what is the base function which has been used, so you can simply say that everything is going to be same, nothing is going to change basically, right? Everything is going to be same, your loss function is going to be same, your entire input data is going to be same. The only thing which is going to change over here is your what? Is your equation. So here instead of writing maybe in case of binary class classification, so let's suppose if I'm writing 1 plus e to the power minus of mx plus c. So here what I will write in terms of multi-class classification, so e to the power mx plus c divided by summation of e to the power mx plus c. Hope it making sense, right? Hope it makes sense. So basically this is OBO and this is OVR. So now we all know that mathematically, right? Now we all know, and again in terms of coding, just one line of a code, not more than that. So like I'm least worried about a coding part. I'm most worried about the conceptual understanding part, because this is what even people are going to ask you. People will never ask you write a code for it, because everyone of us know that anyone can just call the scikit-learn package and then they will be able to write the code. and that's not a real stuff actually, right? The real thing is this. So here OVO, I think we all are able to understand. So if we have a binary classes, so in that case, how classification is going to happen, how training is going to happen. So obviously training will start, and I believe we all understand the meaning of the training. So whenever someone is going to like tell you training, you should not feel surprised. You should say that, okay, I know the math. Yeah, I know like how training happens. And this is the reason. So when I was talking about a linear regression, I have given you a completely full derivation. Even with the SVM, I have given you the completely full derivation because I knew that is a building block. Yeah. So now OVR, I believe we all understand. So in case of binary, in case of multi, how we are going to do the classification. So any doubt, guys? Anyone? Go with the question. Arvindan is saying that, can you please again explain the cross entropy loss? I mean, break down a little bit. There is nothing in terms of breaking it down. In terms of equation, if I'll talk about, right. So maybe I can again write the equation maybe into a simplified manner. So it's going to be negative of 1 by m. So m is nothing but number of data, I is equals to 1 till n. And then this is the expected y, log of, you can say, so y prediction probability, p I can write, plus 1 minus y into log of same thing in terms of prediction. So 1 minus like y prediction probability and this. So this is basically called as log loss or entropy, cross entropy loss. Fine, guys. Yeah. So again, you can go ahead with the derivation. So basically derivation coming from the same equation, 1 by 1 plus e to the power minus of like a z or mx plus c. So where we try to take a log on both the side and then we try to eventually derive it. Yeah, I think Euron is also going to give you the similar result. Yeah, it's giving you the similar result. Is that same result? Okay, now guys, so moving towards our next algorithm. So the next algorithm called as a binary tree. So binary binary tree. Now let's try to understand how this binary tree is going to work and how this is going to perform a classification and a regression. So binary tree is used for both the purposes, classification purposes and a regression purposes. So in both the case, you can try to use a binary tree, or we try to call as a decision tree, right? So decision, not a binary tree, I would say. Maybe I have like written it in a wrong manner. Maybe I can write that as a more like decision tree. So decision tree, right? Now decision tree can be used for a classification as well as it's called as a called for a regression. So we can try to solve a classification problem as well as I will be able to solve a regression problem with the help of this particular algorithm called as decision tree. Now, first of all, let's try to understand in a just a layman way that what decision tree is going to do. So see, what decision tree is going to do is, so decision tree is nothing but it is going to create a tree like a structure. So tree like a structure it is going to create. Simple. It is going to create basically a tree like a structure. Now, how it is going to create a tree like a structure, I'll be talking about it, right? But before that, just try to understand in a layman way that how things actually happens. So here, what will happen is that it will start splitting the data, and then on a leaf node, so it is going to give you a classification, or maybe it is going to give you the continuous value, which is eventually been used for the regression. Now, so maybe I can try to take a scenario over here that if let's suppose I'm going to a market and I have to buy maybe a iPhone, right? Well, sorry, not iPhone. I have to buy a phone. Let's suppose. So I can say that if a price is greater than maybe 20k, then I'll maybe go ahead with something. And if price is lesser than 20k, maybe I can try to go ahead with something. So this is the kind of a decision even we try to make. So maybe today morning you woke up at 12 o'clock, right? So then you will decide that if I will wake up before 12 or before 11:30, I'll join the class. Otherwise, I'll not join the class. So we keep on taking a decision based on the circumstances in general, right? Same thing happens even with respect to the decision tree. So if price is lesser than price is basically greater than 20k, right? 20k. So let's suppose I'll go ahead and buy the a phone. Then again, so I'll come over here, let's suppose, and here, so we are trying to take a decision that if, so here we have taken one decision that if price is 20k. Now here we are going to make a decision that if a color is jet black, right? Black. If I'm able to get a black phone, I was looking for a black phone with the black like entire body and everything. So if then I'll go ahead and I'll try to buy the phone. Otherwise, I will not buy the phone if this condition is not fulfilled. So here, let's suppose I woke up in the morning, I went to the mall or maybe a market, maybe a shop, and then I asked for the phone that, okay, show me the phone. Now they have started showing me the phone with maybe a different like a pricing. So 20k, and then maybe a 40k, maybe a 10k, and maybe again a 18k. And then color is basically black, red, blue, and then blue, and then black. Now I have to take a decision that whether I should buy a phone, means a yes or maybe no, maybe like a yes, maybe no. So this is the kind of a data eventually I will end up making. I will end up preparing for this kind of a decision tree, or vice versa. Let's suppose this is the data which is given to me. So I can try to perform, or I can try to divide this data into a different like a branches. And then based on that, I can try to create the decision tree. At the end of the day, this is called as a root node. Root node in a technical term. This is basically called as a leaf node. Leaf node, and leaf node will be holding the final decision. So whether it's a classification problem I'm trying to solve, so whether I have to classify the data into a multiple classes or maybe into a binary classes. So again, it can work for any number of classes at any point of a time. And if we are trying to do a, or we are trying to solve the basically regression, so where we are looking for the continuous data. So this decision tree is going to work in both the situation, in both the scenario. So here for this data, so if I have a 20k, right, if price is 20k, so price is 20k and color and then final decision. So let's suppose if price is 20k, right, 20k, and then color is like a black. So where I will go? So maybe less greater than equal to. So maybe I'll come over here. Color is black. So what I will do, I'll try to make a decision is equals to yes. Decision is equals to yes over here. So I'm going to buy the phone. Now similarly, let's suppose if I'll talk about 40, right? So price, so here 40 will come because we are trying to evaluate based on the price called as 40,000. So 20k greater than 20k. So maybe I can try to come over here. Then the color is red. So color is not black. So it will come in this maybe direction. I will not try to buy the iPhone. So price is lesser than 20k. So maybe I will come this side, right? I'll try to come this side, and then maybe based on the color I can try to make a division again, and then I'll try to take a decision that yes, I'm going to buy the phone, or no, I'm not going to buy the phone. So in a layman way, decision tree is nothing but, so we try to build a tree kind of a structure, right? Similar to this, we try to build it, and then we try to adjust it in such a way that it will be able to adopt the tendency or the distribution of the complete data set, so that whenever new data comes into a picture, right? So that new data comes into a picture, so it will just try to go this side, this side, this side, this side, this side, and finally it should be able to reach out to the leaf node. The final node, it should be able to reach out, and then it is supposed to give me a prediction. Right? It is supposed to give me the prediction. In case of a regression, so again, it will reach out to the final one, and then it is supposed to give me the final continuous values. As simple as that. So are you able to understand the philosophy behind a decision tree, guys? I have not talked about a mathematical intuition behind it. I haven't talked about how training happens as of now. I'm just talking about, just in a layman way, that how decision tree will be able to do the interpretation. That's it. Yes? Yeah? Everyone? Fine? Okay. So decision tree is nothing but taking a data, dividing a data set and distributing a data set across a decision tree, and whenever new data comes into a picture, we'll try to follow the same path, right? We'll try to follow the same path. Now, let's try to understand it with respect to the mathematics, because the major problem over here is to build this decision tree. The way we were trying to adjust a line in my previous example or even before, so we were trying to find out the perfect plane or a perfect line. So even over here, what should be my requirement? My requirement should be to find out a perfect tree, right? Perfect tree which understands my complete data. And if I am able to find out a perfect tree which understands my data completely, obviously if new data comes into a picture, I will be able to do the prediction. I will be able to do the forecasting. Otherwise, I will not be able to do a prediction. I will not be able to do the forecasting. So now let's try to understand a complete mathematical intuition behind this entire things. So here, if I'll talk about a classification problem, right? If I'll talk about a classification problem, so at the end of the day, we have to build a decision tree, right? We have to build a decision tree. Means we have to start from the root node, and then we are supposed to build a child node, and then sequentially we have to build basically a leaf node. Yeah, based on the data set again. So whatever data set which has been given to you, based on that we have to build all of these nodes. Eventually that will get converted into my entire full scale tree, and then if something new data will come, I will be able to make a decision. I will be able to do something on top of that. So here the major problem we have is build a tree. The way we were trying to like find out the line in my previous case, right, or maybe a plane we were trying to find out, in the similar manner over here we will try to find out the best possible tree. If I'm able to find out the best possible tree, my work is done. My life will be sorted in general. So here, right, so here the major problem you will be able to find out that how to split the data, right? How to split the data means which part of the data will go on this side, which part of the data will go on this side, again which part of the data will go on this side, again which part of the data will come on this side. That's a major problem. Now to solve that major problem, so we have something called as Gini impurity. Gini, Impurity, Gini impurity. Now, what this Gini impurity says? So it says formula wise, so summation of pi of square. So this is basically called as Gini impurity. So here this pi, right? If I'll talk about this pi, so as you can see, it's a p, which is technically a probability. So pi is nothing but probability of basically a class I in the given node, right? What is the meaning of it? We'll try to derive and we'll try to understand it. Now, so this is one of the factor by which you will be able to derive or you will be able to divide the data. The second factor is, means you can try to use either Gini or you can try to use the second one. Either of this you can try to use. So the second factor is called as entropy, Entropy, entropy. In other word, it's also called as information gain. Now, so if I'll talk about a formula, so formula is nothing but negative of summation of pi log of pi. So that pi is exactly same, right? Pi is same. And then we try to calculate basically information gain out of it. So information gain is nothing but entropy of basically a parent, minus summation of, I can say, S of I divided by S entropy of basically I. So here Si is nothing but subset after the splitting. So this is S is the complete set and Si is nothing but a subset after the splitting. Now This equation looks a little bit overwhelming in a very first place, but yeah, believe me, so this is not very difficult. It's actually very easy. Once I'm going to explain you with respect to the data, you all will be able to understand. And the second part is you don't have to remember about it. It's fine. So I'll try to explain you in such a way that you all will be able to remember for your entire life. And how to do a calculation, even you will be aware about that part as well. This is the reason, so I'm taking the class, right? Okay, so let's try to derive this one. This is what happens in case of a classification. So if we are trying to solve basically a classification problem, if I'm trying to solve a regression problem, right? If I'm trying to solve a regression problem, so here what we try to do is, so we try to find out a MSE in case of regression problem. In case of regression problem with respect to decision tree, DT, right? Decision tree. So we try to find out mean squared error. I believe we all know what is the mean squared error. So 1 by n summation of y minus y hat of a square, right? And then we try to find out something called as variance. So we try to compare with respect to the variance reduction. So variance is nothing but 1 by n summation of yi minus mean of the variance. That's the reason. So I have written over here y bar, not hat. Yeah. So basically, this is something which is these are the two equations which has been used in case of a regression. So if you're trying to solve a regression problem, you will end up using these two equations. And if you're trying to solve a classification problem, then you will end up using Gini or maybe a entropy, which is called as information gain. So one by one, let's try to understand and let's try to see that how we can try to perform this equation and how we'll be able to perform this entire things and how I will be able to create a decision tree. So once we will be able to create a decision tree, then you will feel confident, right? Then you will feel confident for a classification as well as for a regression. So let's try to do it, guys. And like I said, you don't have to remember any of the equation. You will be able to remember automatically, right? You will be able to remember automatically. Okay, so here I'm going to take one data, and with respect to data, I'm going to do the complete calculation because I believe here calculation is very much required. So here I'm going to take this data, and this is for the classification problem. Similarly, I'm going to take a data for a regression, and then I'm going to explain you that how calculation actually happens in terms of a regression, means how actually we will be able to build the decision tree. Okay. So here, let's suppose I'm taking a data with respect to a student. So let's suppose there is a student, 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 and then there is a study hour, studyhour, study hour, and then basically previous score is given to you, right? And then basically there is a pass slash fail, the final one, right? So let's suppose there is a student A, right? There is a student B, there is a student C, there is a student D, and there is a student E. So there are 5 students basically. Now, so A study for like a 2 hour, B study for 3 hour, C study for maybe a 5 hour, and then D study for 7 hour, and then E study for 8 hour. Yeah. So student A, B, C, D, and their study hour is given to me. Their previous score, let's suppose, is basically 50. And then basically it's a 55, then it's a 65, and then it's a 75, and then it's basically 80. And yeah, so data is given to me 0, 0 means they failed, and then 1, 1, 1, all 3 passed. So this is basically a data which is given to me. Now, so this is basically a data which is given to me over here. Now let's suppose if I'm going to introduce a student A, B, C, D, E, F. So student F. Now this student study maybe for 6 hour, and his previous score was basically 68, right? Now you have to find out, or you have to do something so which will be able to find out whether this student is going to pass, student F is going to pass, or student F is going to fail. Making sense, guys? The problem statement and the data. Yeah. So I'm talking about a classification problem. We have two classes, pass or fail class as of now. I can have maybe 3 classes, 4 classes, 8 or 10 classes, doesn't matter at all. I will be able to solve even for that. But just for the calculation simplicity, I'm taking 2 classes over here, right? So this is the data which is given to me. Now, I can solve this problem with the help of logistics. With the help of even SVC, I will be able to solve this problem, right? But I have to solve this problem with respect to a decision tree. That this is the data which is given to me. There is a student F, right, which is a new student. I don't know whether that student is going to be pass or that student is going to be fail. My system is supposed to do this kind of a prediction. My system is supposed to give me the result that, okay, this student is going to be pass or this student is going to be fail. So to do that, right, to do that, can I say that we'll have to build some sort of a, if I'm trying to solve this problem with respect to decision tree, so this kind of a tree I have to build first, guys. Yeah, based on the previous data which is given to me. Can I make a statement like this? Everyone, yes, no? Yeah, if I have to do a prediction, so can I say that I have to build a kind of a tree based on the previous data, the data for which we have like a final class? Yeah. Okay. So obviously we'll have to build a kind of a tree so that I will be able to, build a tree. And if I have a tree with me, I will be able to, just pass this data into my tree, which I am going to build. And leaf node is eventually going to give me whether I'm going to be pass or whether I'm going to be fail. As simple as that, right? Now, to build a decision tree, right, we are going to start from the root node, right? We are going to start from the root node. Now we have to divide. Now when we are trying to divide actually, right, so I don't know that we have to divide based on the study hour that we have considered or based on the previous score. Because if I'm talking about a root node over here, if I'm talking about, and this is where many people gets confused, guys. So please try to focus over here for at least 5 to 10 minutes. Otherwise, you will not be able to understand. Many people get confused over here, right? It's a very simple concept, but still. So here, a root node. So at any one node, you will be able to, it's not like take a multiple condition that previous score is greater than this or study hour is greater than that, lesser than that, then go on this side or go on that side. Means go on right side or go on left side. No. So at any point of a time, so basically on a root node, so you are supposed to choose one. Maybe you should choose a score. If a score is greater than this, go on left side. Otherwise, go on right side, right? And then maybe on a next step, right? Again, I can go ahead with the previous score, or maybe I can go ahead with the study hour, that this, and then study hour is this, go on this side, go on that side, right? So I'll keep on dividing the data in this way. But how I will be able to divide that data? That's a major problem. That's a whole things behind this decision tree that we have to understand. So here, what I will do is, so I'll try to take a Gini impurity. So Gini impurity says that 1 minus summation of a pi square. This is a very simple equation. This is what Gini says, right? So I'll be talking about this Gini. Now here, let's talk about the Gini of the whole data, right? So Gini impurity of the whole data, if I'll have to calculate. So here, if I'll talk about a Gini initial, right, or like a Gini of the whole data, pass and fail. So what will be the Gini? So how many pass we have? So basically pass we have as 3, right? 3, 1 we have. So basically like pass, and then how many fail we have? So basically fail wise we have basically 2 over here. Yeah. So probability of pass if I'm going to find out, and probability of fail if I'm going to find out. So probability of pass is nothing but 3 by 5. Probability of fail is nothing but 2 by 5. Total we have 5 data. So if I'm going to ask you a question that what is a probability as per this data, what is the probability that people are going to fail? So obviously you can say 2 by 5. What is the probability that people are going to pass? 3 by 5. Total number of data is equal to this one, right? So fine, we are able to find out this particular point of a time. Now, so if I'll have to calculate a total Gini over here, so Gini is nothing but 1 minus summation of all the probability. So summation of all the probability means what? So summation of basically 3 by 5 of a square plus 2 by 5 of basically a square. So what is this value? So 3 by 5 of a square. So 3 by 5 of a square is going to be technically 3 by 5, right? So 0.6. So 0.6 of a square plus here, so 0.4 of a square. So 1 minus like a 0.36 plus 4 into like a 4 to the power 2. So 4 ke 16, 0.16, right? So here this Gini is going to be 0.48 if you are going to do the calculation. So Gini is going to be 0.48. So basically Gini initial is equals to 0.48. This is something that we are able to find out. Now what I will do with this information? Obviously I'm able to find out this Gini, but what I can do with this information, right? It looks like a completely useless information for me as of now. Yep, looks like, right? Looks like that it's not like a very much useful information so far, but yeah, so I'm able to find out basically a Gini of this pass and like this particular column, which is pass and fail column, which is a Y column. So I'm able to find out the Gini. Gini is equals to 0.48. Now, so we can try to split our data maybe based on the study hour, and we can try to split the data maybe based on the past score, right? So we can try to split the data based on the past score. So here I'll just try to look into the study hour, right? So maybe I can try to split the data based on this. So people who are studying less than 4 comes over here, and people who are studying more than 4 hours, so come over here. As of now, I'm just taking the intuition, right? As of now, I'm just, because this is a trainable thing, right? So system will try to find out, but yeah, here I am trying to do the manual calculation. So I have just considered that, okay, so consider, we can try to consider basically a split at study hour. A split at study hour, let's suppose is equal to 4, right? So lesser than 4. So lesser than 4, if I'll say, so in that case people are failing, and greater than 4, so obviously people are going to pass. So I can say that we are trying to prepare basically a node, right? So here there will be 2 branches, right? This is the parent node. Maybe we can try to create this node based on what? Based on the study hour, right? SH, study hour basically. So study hour, I can say like lesser than, right? So lesser than 4, maybe they will fall over here. So lesser than study hour, lesser than 4, lesser than 4 or greater than 4 will come on this side, right? So here, if I have to find out that whether this is going to be a best split for me or not, right? Whether this is going to be a best split for me or not, how I will be able to find out, how I will be able to figure it out. So here, again, I'll try to calculate a Gini, right? So Gini. So I'll try to calculate a Gini for maybe a left hand side, and I will try to calculate a Gini for a right hand side. So if I'll have to calculate a Gini for my maybe left hand side, and if I have to calculate a Gini for my right hand side, then maybe I will be able to do the calculation. Maybe I will be able to do the math. So here greater than 4, or maybe I can just for the simplicity, if I'm doing left and right, so I can write it in this way, that whatever data which is lesser than 4, or maybe I can write in this way, less than 4, more than 4 will come this side, right? So here on left hand side we are considering lesser than 4. Previously I have considered greater than, but yeah, let's think in this way, lesser than 4 I'm going to consider. There is no purpose, you can try to keep it like interchangeably on any of this side. So we'll try to calculate a Gini over here. Now if I look into this data, lesser than 4, right? Lesser than 4. Now what is a Gini? So what is a Gini for lesser than 4? So basically I'm trying to say that for this subset of the data, what is a Gini? And for this subset of the data, what is a Gini? So can I say that for this subset and this subset, we have only one class 0, 0 for one subset, and for other subset again we have only one classes, which is 1, 1, 1, 1, 1. So here if I'll try to calculate a Gini for left, so it's nothing but 1 minus summation of all class probability, right? So we have basically only 2 data on left hand side. On left side 2 data 0, 0, right? And we just have only one class over here. So we have a 0 by 2 from other class square plus 2 by 2 from other class square, which is eventually going to be 0, right? This is anyhow going to be 0, 2 by 2, 1, 1 square, so 1 minus 1 is going to be 0. So Gini for left hand side is equal to 0. Now Gini for right hand side, if I'll have to find out, so again 0 by 3 plus 3 by 3 square. So again Gini is going to be 0. So for left hand side and right hand side, Gini is going to be basically 0, right? Gini is going to be 0. If, or what is the condition? If I'm trying to split the data on study hour is equals to 4. Now let's take another situation over here, guys, and look at it carefully. So if I'm trying to split at maybe 6, so lesser than 6 and greater than 6, if I'm going to split on 6, so what will be a Gini for left and what will be a Gini for a right? Anyone, guys? So means one side and another side. So what will be the Gini if I'm going to split at 6? So if a study hour is going to be 6 and if I would like to split it at 6, what will be a Gini? So can I say that at a split of 6 means I'm splitting the data based on this. So I have basically like these things. So basically I have two classes, so 0 and 1, and on other side, so I have 1 and 1. So on left hand side, if I'll have to calculate Gini, so 1 by, so we have like 2 by 3 of a square plus 1 by 3 of a square. Now do the math, and then for other side, so 1 minus right hand side. So basically we have two data. So 2 by 2 of a square plus we don't have any other classes, so 0 by 2 of a square. So ideally this is going to be 0, and then this is going to be some values, right? This is going to be some values. So here I can try to split a data even where a study hour is equals to maybe 7, right? At 7 also I can try to split the data, and then I can try to calculate a Gini. Anyone who can give me the Gini at 6 split left hand side? So 2 by 3 of a square, and then like plus 1 by 3 of a square, 1 minus, yeah. So this is going to be some number obviously. Now here, so whenever we are trying to split a data, now if I'm going to ask you a question, right? So let's suppose if I'm trying to build a tree, if I'm trying to build a tree, right? If I'm trying to build a tree, now I have two options. One, split at criteria 6 means where like a study hour is lesser than 6 or greater than 6, and a split at criteria 4, right? So split at criteria 4. How I will be able to decide that, like whether I am supposed to split at 6 or whether I am supposed to split at 4? How I am going to decide, right? So how I'm going to decide that whether I'm supposed to split my data at a study hour is equal to 6, or how I will be able to decide that I have to split the data on a study hour is equals to 4. Now here, right? Now here you must be able to find out, right? So at 6 and at 5. So just give me the this one, guys, left side calculation. So okay, Vikas is saying, Masood is saying 0.43, 0.44. Okay, fine. So I'll be considering 0.44 like that. Yeah, 0.44. So 0.44 is the value. So here I have to take a decision because there can be many values, right? I'm just talking about 5 data, and maybe I can split at 2, 3, 4, 5, 6, 7, 8, 9, 10. On any values I can try to split it, right? It's not like I just have to, there is a hard and fast rule that I have to split at 4, I have to split at 6. There is also a possibility that maybe by like I will try to split at previous score, right? Previous score 50, 55, 65, 75, 80. But on which one? That's a major question. That's a learning things over here. That's a major learning that you all have to get from this particular side. So here, right? So here, what we have to do is, so we have to find out a Gini for a split, right? Gini for a split. Now, so Gini for a split, if I have to find out for 6, so Gini for a split, the data is nothing but, so what is the total number of classes, total number of data we have? 5, okay? Now, we have two classes, 0 and 1. So here, 2 by, right? 2 by 5. And then Gini for left we can try to calculate. So which is basically 0.44 plus 3 by 5, and then Gini for right we can try to calculate, which is equal to 0. Now just do the math, guys. This term is anyhow going to be 0. So Gini for a split for basically 6. Now similarly, just do the math. Just tell me 2 by 5 into 0.44. And similarly, so here, so if I have to calculate Gini for a split at what? At value 4. So it's nothing but 2 by 5 Gini for left is equal to 0 plus 3 by 5 Gini for right is equals to 0, right? So eventually this is going to be 0. Now obviously Gini for like a split at 6 is not going to be 0. It's going to be 0.18. Yeah, 0.18. So here we are able to find out Gini split is equals to 0 or Gini is equals to 0. So if it's equal to 0, it's always says that it's a better split as compared to any value greater than 0 because it's called as impurity. So Gini is equals to 0 means what? Impurity is less. 0 impurity, right? This is called as what? This is called as Gini impurity. This is the reason I have written impurity over here. IMPURITY. Impurity means what? So this is, can I say that this is going to give you a value always between 0 to 1. So closer to 0 means very, very less impurity. Closer to 1 means high impurity, right? So if I have to take a decision that I am going to split the very first node, if I have to take a decision on 6 or on 4, what will be my decision? Yes, guys. So on 4, Gini split is coming as 0. On 6, Gini split is coming as 0.18, some values. So which one I am supposed to take? On which value I am supposed to split? Let's suppose I have just considered a study hour as of now. Only in that situation. Yeah. Yes, guys. So impurity. So impurity should be less. So it simply means that I will be considering 4 over here. Okay, fine. Now moving ahead, right? So here I am saying that okay, I will try to split the data based on this one. That's understandable. That's completely fine. There is also a possibility that I can consider a previous score, right? I can consider a previous score. So maybe a score, and I can try to say that okay, so a score lesser than 60 and a score greater than 60. I can even try to perform that operation. A score lesser than 60, a score greater than 60. So anyone can be a candidate for a root over here, right? Anyone can be a candidate for the root over here. So a score lesser than 50 and a score greater than 60, greater than and lesser than 60. Or maybe I can say that a score lesser than 70, greater than 70. Then again I'll try to find out the Gini. If Gini should always close, or Gini impurity should always goes towards a 0, right? Towards a 0, as low as possible. It simply means that we have a less impurity inside our split that we are trying to do. We are supposed to create as pure tree as possible. So for the best fitting, I would say. Yeah. So okay, we are able to split the data based on 6 and 4. So now we can build a tree over here. We can say that there is a tree, and here, so lesser than, right? So lesser than 4 will come on this side and greater than 4 will come on this side. So now we have this data, right? This data on one side. Let me use some other color. So we have now this data on one side, and now we have this data on other side, right? So now we have one set of the data on this side, and now we have other set of the data on other side. Okay, fine. So what data we have? So we have basically 2 and 3, right? So basically we have like, we can write it down, 2 and 3, 50, 55 and 0, 0. And we have basically 5, 7 and then 8. So 65, 75 and then 85 and then 1, 1, 1. We have this kind of a data. Now what I can do is, so maybe I can create again another split if I have a multiple classes, or maybe I can just leave it as it is. So do I need to split it again, guys, in this situation? Again I can call the split. See, I have splitted the data, right? So now we have two chunks of the data. So on this node, we have this kind of a data. On this node, we have this kind of a data. So we have this kind of a data. I will keep on splitting it, keep on splitting it. But do I need to split now? What do you think? Do I need to split again? Arvindan is saying no. Why? Why we are not supposed to split? Yeah? Why we are not supposed to split over here? Any reason for that? I believe like just look into it and then you will be able to understand the reason. Yeah? Prabhat is saying, Gala is saying, Deepak is saying no. Because we don't need a split. Why? Because there is no further class, right? We have 0 on one side, we have like a 1, 1, 1 in other side, right? So we have like a 0 impurity over here, we have a 0 impurity over here, right? Means, see, if we have like a 0, 0 class and then again we have one class, then we have to split, right? Now, whatever data which will come on this side automatically belongs to class 0. Whatever data which will come on this side automatically belongs to class 1. Yeah. So if we have some such situation like 0, 0, 1, 1, 1 split and then 0, 0, then we'll further split, right? Again, we'll further split. So we'll keep on splitting it unless and until on one side of the node we'll be having one class, other side of the node will be having other class. So we will keep on doing this kind of operation unless and until we are not able to remove the or separate the whole classes, right? So we will keep on increasing the height of the tree. Height of the tree means like we'll keep on extending to the branches. But here we can clearly see that yes, 0, 0 and then 1, 1, 1. So I don't have to split it further because I don't have any other class. I just have only one class on this side, only one class on this side. Fine? Yes? Yes? Fine? Making sense, guys? Yeah? So what about the Gini initial? So Gini initial was 0.48, right? It says that there is an impurity into a data. It says that there is an impurity into data. For example, if I would have given you the data set where I have just 0, 0, 0, 0, 0, 0. So will you go and split the, will you go and create the tree even in that situation? There could be a data where I just have only one class, right? And then maybe like I have a 1 million record. I have basically 1 million record. Out of that record, 99% of the record is basically having only one class, 0, 0, 0, 0, 0, 0, 0, 1, right? So will you go and build a tree over there because my data set is completely biased, right? Let's suppose I'm talking about the fraud detection kind of a cases. So where you will be able to get maybe just 0.1% of the fraud case and the 99.99% of the non-fraud cases. Yeah. So will you go and solve that one directly? No, right? You will do some sort of a pre-processing in a beginning and then only you can send, because there is no meaning of even creating a tree over there. Even if you are going to create a tree, it will be like completely biased and always it is going to give you only one result. Yes. So this is what the initial impurity which I have calculated is going to tell you, that there was an impurity. There was 0.48. 0.48 means a lot of impurity. We are in the middle. So there was a lot of impurity. So we can split it. There is a reason and there is a possibility that yes, I can go ahead and I can try to split it. Is this making sense to all of us, guys? How we are talking about this decision tree, how we are calculating this entire things? Yes? Yeah. Okay. Now I'll try to do the same thing, right? I'll try to do the same thing even for the regression. So this is for the classification. So further classification is not required. Whatever data will come, go on this side or that side. So now we have this data and this data. I have to do a prediction that it should be 1, it should be 0, right? It should be 1, it should be 0. So here, right? So a study hour was, so what is the root node? Root node is representing a study hour. Study hour is greater than 4, right? Which is 6. 6 is greater than 4. So it will go on this side. So it will fail or pass. So here I can get the answer. The answer is 1 over here. Fine. So how entropy in Gini is different? Basically, entropy always, like entropy is using its own mathematical formula. Gini is using its own mathematical formula. Eventually, both are doing the same. Even in terms of entropy, we calculate the entropy of the whole data, and then information gain means a difference we try to calculate and we try to decide. Same we are doing with the Gini split as well, right? Just another formula. Just another way of doing it. So I can try to use maybe a Gini, and I can try to use maybe a entropy, any of this. Now let's talk about a regression case, right? Let's talk about a regression case. So how I will be able to basically do a regression, and how decision tree is going to do a regression over here. So dt regression, decision tree regression. So let's try to understand. So let's suppose if I have a data over here, again I'm going to show you the calculation part. So let's suppose I have a data. So maybe like a simple small data, house data. So let's suppose we have house like H1, H2, H3, H4, H5, and basically the size of this house into a square feet is basically like 1,000 square feet, then 1,200 square feet, then 1,500 square feet, then 1,800 square feet, and then 2,000 square feet. And then price is given to me. So price is basically $50,000, euro, whatever you can consider, then 60,000, then basically 70,000, then 85,000, and then 95,000. Okay. So this is the data which is given to me. Now let's suppose we have a house H6 and basically its size is equals to, let's suppose 1,700 square feet. Now what is the price? This is the question. So here, this is basically a regression problem, right? We have to find out some sort of a continuous value. We all know about it. Yeah. So we have to find out some sort of a continuous value over here. How I can try to use a decision tree and how I will be able to find out these values. That's a question, right? With the help of decision tree. I can even try to build maybe a LR, linear regression. I can try to do it. But yeah, we have to find out with respect to a decision tree. So how I will be able to do it. Let's try to understand. So here what I can do is, so like I have already mentioned in a very beginning, that in case of regression, so mean squared error and variances we are going to calculate. So here what I will do is, so I'll try to calculate basically mean squared error. Now what is this mean squared error, by the way? So mean squared error is nothing but 1 by total number of data y minus y bar of square, let's suppose, right? Which is y bar is nothing but the average, right? The average. So here what is my y bar? So if you are going to calculate the y bar, so 50,000, 60,000, 70,000, 85,000, 95,000. So if you are going to find out the average of it, it's going to be 72,000. I have already done the math, so I know the value 72,000. You can even do the math. So this plus this plus this plus this plus this divided by 5. It is going to be 72,000. Now, so MSE initial, if you have to calculate, so what it is going to be? So y minus means 50,000 minus 72,000 square plus 60,000 minus 70,000 square. So 50,000, then 70,000 minus 72,000 square, 85,000 minus 70,000 of square, 95,000 minus 70,000 of square, and then divided by total number of data, which is equal to 5. So this is going to be the MSE. Now, if you are going to calculate initial MSE, mean squared error, right? Initial. So it is going to be 265, 2, 1, 0, 2, 0, and this. So this is going to be your initial mean squared error, right? How we are calculating mean squared error? This formula, simple, right? And we have a y average. So this is going to be the value you will be able to find out. Now, this is not going to help me out. So this is my mean squared error. Means there is a lot of error. There is a huge error which I am able to find out over here. And I have to create a tree. So if I have to create a tree, so maybe I have to find out a decision point lesser than equal to, lesser than or greater than, right? So that my data can go this side, my data can go this side. So I have to find out this breaking point over here. How I will be able to find out the breaking point? So maybe I can try to take this middle values manually, right? Although system is going to learn this one. So here I'm going to take the middle value. So let's suppose if I'm saying that split size is going to be 1400, right? 1400. So if size of the house is lesser than 1400, come left hand side. If it is greater than 1400, come right hand side. Yeah. So maybe I'll try to split the data based on 1400. As of now, it could be 1700, it could be 1800. So we'll do the experiment, we'll do the math, and then we'll try to check that out. Yeah. So which one is working well for me? So here I can try to decide that okay, so let's try to split the data based on the 1400. So if 1400 lesser than 1400, come on this side, greater than 1400, go on that side. So here, if I'll try to do such kind of things, so in that case, what will be. So if like a 1400 split if I'm going to do, so basically I'm trying to split based on this. So we will be having this data, and we'll be having this 3 data and 2 data on one side. So here, if I have to do the math, so y average is going to be basically my 55,000, and then here y average is going to be for a greater than like this one. So y average is going to be basically, so this is let's suppose left, and this is let's suppose for a right data splitting purposes, 8333.33. So this is something which I'm going to get for y average. Now once I'm able to like aware about a y average, so obviously I have to find out a mean squared error for my left. So mean squared error is nothing but data minus average square summation of it divided by total number of data. So we have 2 data on left side, 2 data on right side. This is what I have assumed. So here my MSE for a right is going to be, it's again going to be very huge number. So 105555. So 1 2 3 4, then 5 5, and then 6. This is going to be your mean squared error for a left, and mean squared error for a right, if I'll be talking about sorry, my bad. Okay, so here this 3 mean squared for a left is going to be 25. It's a very big number, and then 60, and mean square for right is going to be basically 10, then 65, and then 6. So this is a mean squared for a left, this is mean squared for the right. When I'm splitting, right, when I'm saying that, okay, so like a flat size is lesser than 1400 square feet, come this side, flat size is greater than 1400, come on that side. Now if you are going to calculate MSE for a split, MSE for a split is nothing but basically it's going to be the probability, right? Probability with respect to the data. So 2 by 5 of left hand side, so 25000000 plus basically 3 by 5. On right hand side we have 3 data, so into 10555556. Fine. So here MSE for a split is nothing but left and right, so both we are trying to combine, and it's going to be 7333 7 1 2 3 3 3 3 3, yeah, 7. So here, right, so here this is basically MSE for a split we are able to find out, and this was a initial mean squared error we were able to find out, right? Now which one is greater, guys? MSE for a split is greater, all 3. So 7, after that we have a 7 3, and we have like a 2, after that we have 8 numbers, and we have 7, after that we have 7 numbers. So which one is a small? So MSE split that I have calculated is small, or MSE initial is small? Which one is small? Yeah. So initially I have calculated basically a mean squared error, and then I have just splitted the data, and then I have calculated the overall mean squared error. Which one is small? Yes, guys, which one is small? Just by look into the number. The calculation is very easy, right? So can I say that MSE initial, so MSE initial is actually greater, right? Greater than this one, means if I'm going to split the data, can I say that I'm going to reduce the error? Can I make a statement over here that if I'm going to split the data, I will be end up reducing the error? Yes. Yeah, because MSE split is basically lesser. If it would have greater than the initial one, then obviously even after splitting, I'm not going to reduce the error. So I should not go ahead with the split, right? Here I have considered 1400. Maybe I can try the same thing out with 1700. Maybe I can try the same thing out with 2000, right? Now, whichever is giving me a less split, right? Maybe even lesser than this. Someone is giving, maybe 2000 is going to give you maybe lesser than this one, right? So in that case, what should be my split criteria? So my split criteria will be that number. So maybe 1400, maybe 1700, maybe 2000. Same thing we have done even before, right? So why we have selected 4, split at 4, not at 6, right? Because 4 was giving me less Gini, means less impurity. Similarly, so here 1400, maybe you can go ahead and calculate with respect to a 1600 or 1700. It should be obviously lesser than NSE, initial. It will be lesser than MSE, right? And basically, and if you are able to find out some MSE after some split, maybe on 2000, maybe on 1700, maybe on 1800, maybe on 4000, right? Whatever you want, right? Whatever you want. If you are able to find out something lesser than that, just go ahead. It's fine. Not an issue at all. Yeah, not an issue at all. So you will be able to split it. So as of now, I'm going to split it on a 1400 square feet. So on 1400 square feet, if I'm going to split, so lesser than 1400 will come over here, greater than 1400 will come over here. So maybe I can try to split my entire data in this particular manner, right? In this particular manner. So maybe I can try to split my entire data, saying that house H1, house H2, a square feet is basically 1000, and then here we have like a 1200, and then price is going to be 50,000, and then price is going to be 60,000. Now on right hand side, we have technically 3 data, right? So we have like H3, H4 and H5. So we have basically 1500, 1800, 2000, 1500, 1800, 2000, right? And then we have basically 70,000 as a price, and then we have 85,000 as a price, and then we have 95,000 as a price. Okay. So we are able to build the split, right? I can further split it. I can further split it if I want. I can further split it, right? Because now we know the Gini of this individual, right? Even we know the Gini of this individual. You can even calculate it. So if I'm going to ask you, sorry, not a Gini, my bad. So we are solving a regression, right? So we can try to find out a MSE of this. We can try to find out a MSE of this. We are already aware about it. We have already done the math, right? MSE left hand side, MSE right hand side. So here, if we are splitting it, and if it is going to reduce my MSE, that's fine. Reduce it, right? Keep on splitting it. Keep on splitting it. So here I'll split it. Okay. So splitting wise, fine. Let's suppose finally we are able to create only this particular tree on this side, on that side. Now, what was my question? My question says that if size is going to be 17,000, what should be the price? That was my question, right? I have to give this particular answer based on the tree that I have created. I have to give this answer. So if basically size is equal to 1700, then what should be the price? So size 1700 will come on left side or right side, guys? This is my left side. This is my right side. So which will come on this side? Which side? Yeah, it will come on which side? Left or right? If size is 1700. Guys, right hand side, right? Okay, it will come on right hand side. Size was 1700. Now, price. What will be the price, by the way? What will be the price? It's coming on right hand side. That's fine. 1700, right? 1700 coming on right hand side. What should be the price? How I can calculate the price? Yes, guys, how I can calculate the price, by the way? Arvindan is saying average of all 3. Exactly. That's a correct answer, right? So we have this data. What should be the price for this? Average of this. Average of this. 17,000 plus 85,000 plus 95,000 divided by 3. That it is going to be the prediction. That is going to be the price, at least from this step. right? The tree that we are able to build. So this is how regression happens. This is how it will be able to find out. So it will keep on splitting. So I have just taken this very small data, because even you can see that how complex, like not a complex, it's not a complex calculation, I would say, but yeah, bit of lengthy one, right? So it became little bit of lengthy one. So you can try to take any kind of a big data, and you can do the manual calculation. That's fine. Yeah. So the major point over here is, so we have to find out the split criteria which falls, which is going to like eventually define on each and every node. So even this is the node, this is the data. I'll keep on doing it, right? I'll keep on separating this entire data set, and unless and until I'm not able to create the further separation, so where I'm not able to reduce the error or impurity. Is this making sense to all of us, guys? How decision tree actually works? So if someone is going to ask you like do it mathematically, each and everything in 5 minutes, will you be able to do it? Yeah, Arvinder is saying similar to entropy we can use. Yeah, entropy or Gini. Entropy and Gini both are same actually, like not formula wise. Formula wise both are different, but yeah, eventually helping you out to do the same thing. Yep, everyone. Fine. So you all will be able to explain decision tree regression as well as classification both. So goal is very simple. In case of classification, always try to minimize the impurity. So and in case of like a regression, so always try to like minimize the variances. That's it. Apart from that, like there is no goal at all. Here the learning basically is splitting the data. Exactly. This is what we are trying to like split the data. And again, so we are trying to find out the criteria, right? We are trying to find out the criteria. So we have to find out this criteria. This is called as learning. So every time, so we have to find out the best criteria basically. And that too, if we have maybe like tens of columns. So for every column, we have to find out the criteria. Mostly we use a Gini to reduce the computation. Yeah, that's correct. That's a correct statement, Prabhat. Because Gini calculation is bit less lengthy as compared to the entropy calculation. So generally we use it. But even if you are going to use a Gini, or if you are going to use an entropy in case of classification problem solving, it's not going to make any kind of changes. It's like going to be like almost same. But yeah, computation wise, Gini is less expensive, you can say, and entropy is bit more expensive. Hope guys I am able to explain you the entire thing. Yep. Sir, if we have a LR means logistic, you are saying, right? Or linear, then why we will be using a decision tree for a regression? It will give a good result. I'll come to that point as well. Don't worry, right? See, linear regression is going to work for you. So when you have a linearity into a data, I think you remember I have plotted the dot scatter plot. And then let's suppose I don't have a linearity into a data. Right? I don't have a linearity into a data. Let's suppose I have a zigzag kind of a structure, data wise. Then will you be able to use, and I told you even at that point of a time, right? And that's the reason. So we talked about even polynomial. So regression wise, I think this is not the first algorithm that we are talking about. We already talked about polynomial. I even talked about SVM, right? So basically, every time you can't use a linear regression, because linear regression is having a lot of limitations, right? That data should always show you the straight line tendency. Let's suppose I don't have the straight line, then what you will do? I'll go ahead with the polynomial. Maybe I'll go with the SVR. Maybe I'll come with go ahead with the decision tree regressor. Making sense? I think you got your answer. Deepak is saying, sir, explain it very easily. Looks like these are a very easy concept. All this machine, believe me, all this algorithm that you will learn even till a very last, which is going to be a transformer kind of a research paper. Actually, it's not difficult. And it's, believe me, it's very logical. The beautiful part is, it's very logical. Even though there is a mathematics, but people, I don't think that, I mean, like what kind of mathematics we are doing? Like just plus minus kind of mathematics? Don't come and say that we are using some heavy mathematics over here. We have not used the heavy mathematics anywhere. Just a simple derivation somewhere we are using, somewhere plus, then minus, then this MSE, and then some time like a log loss, cross entropy. Only this kind of a mathematics we are using. So I don't think that these are the difficult things to understand and learn. But yeah, important one. in your interview, obviously. Without this, you will not be able to like crack the interview. And if interviewers is like me, so obviously I'll not even ask a single question in implementation. I'll grill you just on algorithm. Because I know if you understand the depth of the algorithm, you can build the things as a machine learning engineer. Okay, fine. Coming to the next part, guys. So there is an algorithm called as random forest, RANDOM, random forest. So basically, random forest is nothing but it's an extension of the decision tree that we have discussed. Again, it's been used for a classification as well as it's been used for the regression. Now, what is the meaning of a random forest? So basically, random forest is called as basically ensemble learning technique. So there is a term you all are going to encounter, and that term meaning is not very like difficult to understand. Ensemble learning technique. Now, what is the meaning of this ensemble learning technique? So ensemble learning technique is nothing but, so where we are not just having only one decision maker, we have a lot of decision maker. That is something called as ensemble learning technique. Means everyone is going to give a vote or everyone is going to participate. For example, so if I have to shift a timing of your class, so obviously I can't do it by myself. Let's suppose I am one of the decision tree, right? And all of my students are again other decision tree. So if I have to take some decision that whether I should change a time or I should not change a time, yes and no. Answer should be yes or no, right? And maybe like a value, right? 2.5 hour of class I have to take, or maybe I have to take a 6 hour of class, right? So maybe a value means regression classification, both the cases. So in some of the situations, so it will be better if I'm going to take a decision on my own, if I'm going to shift a timing of this entire class, maybe at 9 p.m., right? Now, everyone will start blasting. Some of you will even go on like a social media and write some sort of a negative comment over there saying that Sudhanshu Kumar is a very bad mentor. He changes a class timing without asking anyone, blah, 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 right? And there could be a second situation. So where I can ask you, right? I can provide information, means data basically to all of you. And then I can ask you that, okay, fine. So let's take a decision. Now, if I'm going to take a decision, then there is a very less chance, right? There is a very less chance that that decision will be wrong, right? And no one is going to like create any kind of escalation in that situation. Yeah, no one is going to create a kind of escalation in that situation, and decision will be not biased. So decision is going to be more robust. So the second approach, right? The second approach is called as ensemble technique. So where only there is not just a one single decision maker, but there will be a multiple decision maker, and the final decision is going to be a majority wins kind of a situation in case of classification, and in case of regression, the average out. Fine, guys? Yes? Yeah. Anu, so most probably by next week, so like a little bit of work is still like there. So people are like, my developers are doing it. Do I need to learn this by doing a mathematics? Obviously, you have to learn it by doing a mathematics. That's the reason. So I'm explaining you mathematics. Otherwise, I would have just called one simple library and told you that, okay, your decision tree has been built. Enjoy. Yeah. So here, basically, the situation over here is that instead of taking one decision maker, maybe we can try to take an input from a multiple decision maker, and that is called as ensemble learning technique. So where there will not be just one decision maker, means there will be multiple trees we are going to create, and then everyone is going to make a decision, and then in case of classification, so it will go for the voting, and in case of regression, it will go for the averaging. But yeah, so we'll be having decision maker 1, we'll be having decision maker 2, we'll be having decision maker 3, as many as we want. So we can try to create a decision maker, and then eventually we are going to take a final decision. Okay, so that is called as, so wherever there will be a multi-party will be involved in terms of making a decision. So that's something called as a ensemble learning approach or ensemble learning technique. Now, this is where random forest comes into a picture. So random forest is one of the algorithm. Likewise, so there is something called as there is something called as XGBoost, ADA boost, gradient boosting. All of these things falls under ensemble learning technique. So where there is not just one decision maker, but a multiple decision maker. Now, as you can see, the name suggests that it's a forest. Forest means collection of tree. We have already discussed tree. So forest means in a layman way even. So forest means what? Forest means just a collection of a tree. So basically random forest. What is the meaning of a random over here? We'll try to explain you this. So let's suppose we have a data, right? So let's suppose we have a data. Maybe we have like this kind of a data over here. So someone has given me a data. Now, so here we have like multiple columns over here. We have multiple columns over here. So maybe like we have a column C1, column C2, column C3, column C4, and then we have basically Y, right? And then maybe we have a data sample over here. So maybe sample A, B, C, D, E, F, G, H, okay, G, H. And then again, we have some sort of a number in column for column 1, 2, 3, 4, 5, 6, and then we have a classes, maybe 0, 0, 0, 1, 1, 1. Something like this, right? This kind of a data. And then all these numbers we have, or some data we have over here in numbers or categories. That's fine. Now, so how this tree is going to be trained? So let's suppose if I'm talking about decision tree 1, decision tree 2. So we all know that what tree does, right? We all know what tree does. So we are just supposed to pass the data over here. It will keep on splitting it and it will keep on doing it unless and until it is not able to reach out to the leaf node. So we all understand, and just now we have seen that how training of the tree happens, right? So I know that if I'm going to pass a data to this particular tree, so how it is going to split and then how it is going to build something. Then I know even for this, even for this. But are we supposed to pass this whole data? This is my data, let's suppose. This is my whole data. So are we supposed to pass whole data to this one, and to this one? Yes or no, guys? Are we supposed to pass this whole data? When I'm saying whole data, it simply means that I'm talking about all the records and all the columns over here, all the rows and all the features over here I'm talking about. So are we supposed to pass all the data to D1, all the data to D2, all the data to D3, or so on, DN? Yes or no, guys? So Arvindan is saying no. Okay, Deepak is saying no. Obviously, if I'm going to provide all the data to everyone, then eventually everyone will end up building the similar kind of a tree, because everyone is going to calculate maybe a Gini or entropy in case of classification, MSE and variances in case of regression, and eventually everyone is going to do the similar kind of a split. So here, right? So here what we do is, and here what random forest does is that ensemble technique, it's by default it's an ensemble technique, means there will be a multiple parties involved for a decision making. Now what random forest does is that it will try to split a data. So there is something called as, there is a term called as bootstrap sampling, BOOTSTRAP, bootstrap sampling. Bootstrap sampling. Again, don't go after the fancy terms over here, right? So meaning is very, very simple. So here, what is the meaning of a bootstrap sampling, guys? So bootstrap sampling means, so randomly it is going to select a record. So maybe it is going to send a data to a D1, let's suppose, right? It is supposed to send a data to the D1 and then D2, then D3. So maybe it is going to send A, B, C, D and G to maybe D1. Yeah, A, B, C, D, G to D1. Then maybe to D2, it is going to send a record B, C, D, E, F, G. Possible. To D3, it is going to send a record maybe like a B, D, E, F, G, H. Something like that. So it is going to send some record to this one, some record to this one, some record to this one. And there is a possibility that there will be a commonality between the record. It's not like if D1 has received some record, so D2 can't receive it. No, that's not a meaning of bootstrap sampling. So bootstrap sampling says that we are randomly select a subset of the data with replacement. With replacement means like there will be an overlap. Yeah. So with replacement, so some data will go to this one, some data will go to this one, but there will be an overlap. There is a possibility that A will be a part of A, B will be part of this, plus this, depends, right? So randomly it is going to select some record for a D1, for a D2, so that randomness it will be able to create, and that technique is called as basically a bootstrap sampling. Is it making sense to all of us, guys? Yes. So this is one part in terms of, I'll say, a row record. Now, does it even do a randomization with respect to a feature? Yeah, that's again a question. So record wise, so yes. So record wise, it is going to randomly select, but with overlap. I'm not saying that it is going to send unique record to D1, unique record to D2, unique record to D3. No, not at all. Right? So this is on a row label. Now, what about a column, or what about the feature? So does it create this kind of a randomization with respect to even a feature or the column that we are talking about? Yes, it does. So it is going to create, and even when I show you the practical example, so there is a property, there is basically a parameter that you can try to select. So here it will do a row randomization as well as it is going to do a feature randomization. For example, we have 4 features, C1, C2, C3, C4. We have 4 columns. There is a possibility that D1 will just receive C1 and C2. D2 will receive maybe a C2 and C3. D3 will receive C2, C3, C4. Right? So some will take maybe one, some not one, like maybe 2. Right? Someone will take 1 or 2. Someone will take 2 or 3. Someone will take whole. Right? So even a feature randomization and a row randomization we are supposed to take, and then we are sending a data to a different kind of a decision tree basically, right? So that there will be a complete randomization across all this decision tree, and finally it is going to give me a decision. And once all the decision maker is going to give me a decision, so in case of classification we'll go for the voting. So majority wins, right? Voting means majority wins. So whether it's a 0 class or it's a 1 class, right? And in case of a regression, we'll go for the averaging. So whatever, like every decision tree is going to give me some record, right? And then I'll try to average it out, and that is going to be the final result for a regression. And we all know that how base tree will be built. So the logic behind building a base tree has not changed. It's same that I have discussed with respect to a decision tree. Yep. So in this case, right, in this case, basically you will be able to remove the overfitting, because now there are overfitting means what? So at the time of training, accuracy is maybe more, and at the time of testing, so accuracy is, let's suppose, less. That's something called as overfitting. Means with respect to the unseen data, maybe model is not giving you same accuracy which it is giving you with respect to the seen data. That is something called as overfitting. So now when multiple decision maker is going to be involved, so obviously it will be able to reduce the overfitting. The example I have given you, right? So if I'm going to take some decision on my just I'm going to take a decision like change the timing of the class, maybe most of you will blast. And if I'm going to ask everyone, if I'm going to take a buyings from everyone, then none of you will blast, right? So there is a very last chance. There is a very less chances that people are going to blast, and people are going to go on social media and post something. So because yeah, nowadays everyone posts on social media without even thinking about anything. So yeah, that's a reality. But yeah, so here basically it will help you out to reduce the overfitting at the end of the day. Very simple, right? So it is going to send a random data based on row record as well as feature. So if someone is going to ask you a question that is it going to even split the data or randomize the data or bootstrap the data, bootstrap selection of the data even based on the feature, the answer is going to be obviously yes, it is going to do it even based on that particular part. Yeah. So advantage, obviously, so you will be able to get a higher accuracy, robust to the noises, and it will be able to handle a missing data, feature importance, right? Missing data, how it will be able to handle? Because we are splitting, right? In some of the columns, so there is a missing, there is no missing, it will be able to handle. But yeah, disadvantage is it is little bit computationally expensive and then like a slow prediction, but that's completely fine if I'm able to get a good prediction. So fine guys, this is all about a random forest by the way, right? And we have already discussed about a decision tree. We have already talked about basically a support vector machine. We have already talked about a logistic regression. So I believe today we are able to talk a lot about the algorithms. Now tomorrow, first of all, I'll try to do one thing. So I'll try to take 2 class and then I'll show you the classification. Then I'll take a multiple classes. Then I'll try to show you the classification. Then even a regression, I'll try to show you with respect to all the algorithm that we have discussed so far, so forth. And as a homework tomorrow, not today, as a homework, I'm going to ask you to build a Streamlit app. I believe we all know how to build a Streamlit app, how to deploy those things on a cloud platform. So that will be the agenda for tomorrow. So I'm going to write a code and I will do a EDA operation, data cleaning for a two class classification, for a multiple class classification, build the model, test the model, check the accuracy of the model, and then finally you guys are going to deploy the model. So let me take some question by the way. So Deepak is asking, sir, bagging and bootstrap. See, bootstrap, bagging, both are like different technique. Like don't try to mix it. So don't try to compare apple with the orange, because bagging is apple, the other one is bootstrap is orange basically. So bagging means what? Bagging means I'm trying to bagging is a technique. So here I told you, right? So ensemble is one of the techniques. So it's bagging inside a ensemble technique. So ensemble means language wise or maybe definition wise, what is the meaning of ensemble? Maybe where there will be a multiple decision maker, right, will come into picture, that is called as ensemble. Now inside ensemble, right, inside ensemble there is something called as bagging and there is something called as boosting. So again it's been categorized, bagging and boosting. Bagging means, so we are going to create one single bag, there will be multiple decision maker over here, and then all of this is going to make a decision and finally I'll be able to get the result. That comes under bagging. So again just a keyword I would say, or buzzword, bagging. Now boosting means what? So there will be a multiple decision maker, there will be a multiple decision maker, so one will try to evolve from the previous one and then finally it is going to give me the decision. That's called as boosting. Keep on boosting the next one, right? Keep on building the strong decision maker, the next one is going to be the strong decision maker. So basically the random forest that we are talking about, it falls under category of bagging and then eventually under category of ensembling. Bootstrapping is basically a concept to split a data, to provide a data to all of these decision makers available inside a bag. Is it making sense? So you should not compare even bagging and bootstrapping. You can compare bagging and boosting. So yeah, there is a comparison between a legit comparison between a bagging and boosting. You will be able to find out. But bootstrapping is a technique of splitting a data. I hope I'm making sense to all of you. Yeah. Ganesh saying bootstrapping aggregation is equal to bagging. No, bootstrap is basically, think about it in this way. Bootstrap is always about splitting a data, providing a data to all the decision maker. Bagging is just an approach which falls under ensemble. Ensemble means what? Wherever there is a multiple decision maker. Now even here we have a multiple decision maker and even here we have a decision maker, but arrangement of the decision maker is different. So here we create a bag, means all of them will collectively, like a parliament, right? Like a parliament. So all of them are going to collectively make a decision and average is going to be, or maybe majority wins is going to be like a final decision. Now here, right here, let's suppose like a dictatorship, I would say. So I'm trying to make some sort of a decision. So maybe it will start chaining. So it will start from the very low layer, but eventually the final dictator who will be having more capability to make a decision. So maybe he will ask something from his, take some input from his counselor, then previous one will take some input from the previous one, the previous one, but eventually one is going to take a decision. But even here, so to take a final decision, multiple people are involved, right? Multiple people are involved to take a final decision in this place. So in both the things, multiple parties are involved, but in one places, in a different way, multiple parties are involved. In other places, in a different way, multiple parties are involved. So there is a bagging and there is a boosting. Just a keyword I can say. Yep. So don't do the wrong comparison. So bootstrapping is just a way to provide a data to all of these decision maker. That's it. Okay, fine guys. So I think I am done for today, by the way, and I'll take your class. Let me share this PDF first of all with you. So today is what, like a 1st of March. So 1st of March, what I have discussed. So basically I have discussed linear regression, LR, then decision tree, then random forest, RF. Okay, so sharing. Fine. So I have just uploaded this PDF, guys, inside your resources. I think we all know what is the agenda for tomorrow. So agenda for tomorrow is going to be simple. We'll go ahead with the practical. Then I'll give you like a homework for a week, so that, and tomorrow I'll give you not just a deployment part or creating a Streamlit part, but along with that I'll just try to add a lot of toppings around it, and then I'll give you so some sort of a even ML ops part I'm going to ask you to perform over there, right? And those who are not aware about it, it's fine. We have a class. We are anyhow giving a multiple classes, so you can go and refer to any of the classes. But yeah, from tomorrow onwards, we'll start building a full scale app. So tomorrow, 4 to 5 algorithm. I believe we have to test. One is a SVR, SVC, SVR, logistic regression, dictionary classification and regression, and then random forest classification and regression. So these are the like 4 plus 3, 7 things we have to test it in a practical way. So that will be learned by tomorrow. And then in upcoming classes, so let me check syllabus once. Syllabus is basically Euron. And hope you all are able to understand. You are not getting bored, by the way. So full stack data science. So yes, syllabus wise, after that I think I'll have to discuss XGBoost, K, mean, all those algorithms. Yeah, so K nearest neighbor, KNN I have to discuss, SVM discussed, decision tree discussed, this one discussed. So naive bias, yeah. So KNN, K nearest neighbor, and naive bias we'll have to discuss, and then we can start talking about the other ensemble technique, so which is called as bagging. Bagging is nothing but same thing we are discussing as of now, random forest. Boosting is basically this one, XGBoost, gradient boosting, light GVM, CAD boost, ADAP boost, a lot of things, right? And then stacking. Stacking is another like a class, bagging, boosting, and stacking. So this will be discussed. So one algorithm, majorly 2 algorithms over here, and 3 algorithms. Okay, so 3 more from here, and then 3 from here. So total 6 algorithm. Yeah. So most probably by next weekend, this all algorithms and its practical will be done, and then we'll try to move into one of the full scale projects. So we'll try to involve cloud platform, Azure, AWS, GCP kind of a platform, ops kind of a things will try to involve over there, and databases and all those things will try to involve, and full scale app we are going to build next to next week. So by next week, I'm assuming that all of these algorithms will be done at least, and then based on this algorithm, so we'll start building, or we'll start doing one of the project which is a part of your syllabus. But yeah, in a full scale manner, so we'll try to do the project. Like, it's not like it's going to be just a Streamlit app. No, we'll try to make it full scale with a DB, with ops, with CI/CD pipeline, with ML ops, with everything, so that we'll be able to deploy it, productionize it in a real time into a cloud platform. So maybe we can try to build this recommendation system out of something. Time series, this can be also done. Sentiment can also be done. Okay, rest is like a vision based project. Fine, we'll have to wait. Okay, and then I'll try to start with the neural network and computer vision. So most probably in next 2 weeks, we will end up doing a complete full scale one end-to-end project, and all the majority machine learning algorithms, I would say, where we will end up using everything. So like when we'll do a project, right? So we'll end up using almost every kind of a technique, because this is the meaning of a project. So it is going to be heavy, because one project at a minimum going to take 4 to 5 hours, not less than that, right? Minimum that much of time is required just to complete one single project, even more than that sometime. It's required to complete one of the projects. So it will be done in that manner. Classification matrices also we haven't discussed. I believe I talked about a classification matrices in my stats class. And again, so when I will try to build the model, because I don't think that so far we have built any kind of a models, right? So obviously we are going to talk about it, because as far as matrices are concerned, as far as formulas are concerned, I already talked about a confusion matrix. If you will go and follow your stats classes, so where I talked about a formula for the precision, accuracy, F1 score, ROC, AUC. Sir, will take the time series using Arima. Arima is nowadays very much old. It's not at all fresh, I would say. So it's better to go ahead with the LSTM, or maybe to go ahead with the Facebook Prophet library. That is having much more like a capability because it's again a deep learning based library. So that can do and that can solve a time series problem in a better way, right? So we should not even learn everything, because I used to teach Arima, Arma, Sarima, all of these models. So ACF, PSCF, its component inside it, right? But again, so if something is not relevant, I don't want to like burden my student to understand some additional concept. But yeah, if you'll go and check my previous classes, or like the kind of a classes which I used to take, so obviously, but yeah, I keep on adopting, I keep on changing things because of like uh, the new things and the demand inside the market. Okay, fine guys. So thank you so much. Take care. See you again tomorrow. Tomorrow, I think we all know the agenda, what we are going to discuss. So let's join again tomorrow. Hope all of you are enjoying the class, and hope you are not getting bored and all of you are able to understand. Yes, everyone guys. Just say yes in group and group chat, and then maybe we can close the class. After ML, can I apply for the job? Yeah, you can start applying for the job. Maybe you can just, I'll give you a couple of like a assignment, and assignment in terms of not just a small assignment. So I'll try to ask you to build a couple of things, build it, put it inside the resume, and start applying for the job for a machine learning. Yeah, enjoying. You never disappoint us, sir. Thanks for explaining easily, clearly. आज बहुत new concept. So thank you, दीपक जी. Thanks. Yeah. Hope कि आप सभी लोग ऐसे सीखते रहेंगे. ठीक है. Okay, or app, guys, any feedback for a app, by the way? So I think now app is available worldwide. So it doesn't matter whether you are from US, UK, Canada, Europe, maybe Africa, Australia, or maybe a Singapore, Vietnam. I think our app is now available everywhere except China, because there is a restriction, right, in China. But maybe you can use a VPN, you can download it if you're from like China. There are a couple of people yesterday, day before yesterday, a couple of people pinged me in a chat, like they said that they're from China. I said, okay, amazing. That's great to know. Yeah. So soon we are planning to even release a iOS app. As of now, only Android is available. But yeah, now Android is available globally. By next weekend, you will be even able to get a download feature. So we are like releasing a update by next weekend, I would say. Next weekend or maybe before that, because we have already built it. But the problem is like it goes to App Store and they take time. And we can't say that how much time they used to take. Maybe sometime they take just like a 24-hour of time and approve it. And sometime they take maybe a week of time and they disapprove it. Then again, we have to do something, and then again we have to submit it. So back and forth, back and forth. And this is something which is going on even with the iOS app. So we have already built it a month back, but we are struggling to publish it because of their compliance issue, then country-wise restrictions, many things actually comes into a picture. So when you release something country-wise, especially app, Play Store or App Store. So by next weekend, again, the very much needed feature, which is a download feature, will be available, so that you all will be able to enjoy your class even in a offline mode. Let's suppose you are traveling, you are into a complete no internet zone mode. So you can download it just like any other, like a Netflix or like a Amazon Prime or Disney Hotstar kind of a platform used to give you, and even YouTube gives you, right? And yeah, so you can just go ahead and enjoy the video. Waiting for iOS app. So yeah, even I'm a like a iOS user. Like regularly, I use the Apple iPhone, and for my testing purposes, I use even Android. So, but yeah, my main phone is basically iOS. Even I'm just waiting for the same, because it's very much inconvenience for me to nowadays to like keep both the phone together for a testing. And we have a small team, so even I used to do a lot of testing. I have to suggest that, okay, let's build this feature, that feature. So even I'm feeling like a little bit of pain over there. So I'm just like we have already built it, but like I said, so it's just a publishing things. When will the resume feature, as I have already posted in a multiple places. So by next week, that will be live next week. So we have already built it, couple of tuning we are trying to do over there. So by next weekend, again, this resume feature will be live just on web. So we are not releasing it as of now on mobile. Maybe in a later stage we'll release it on a mobile, but yeah, just on web, it will be available. And plus a reel feature, like shorts feature, I can say, or reel feature, and or in our case it's bytes basically, plus download feature and couple of more feature we are releasing by next weekend. That will be available in your mobile device, and hopefully soon we'll see iOS app. Could you please give us a demo once it will be released? I mean, like, there is nothing called as demo in that. Anyhow, I'm going to create a promotional video for that, like where I will come and like talk about it. Upload your resume. All things will be done by system itself. It's as easy as it is. So you don't have to do much. That's the reason so we are creating system. Okay, so once it will be released, once it will be public, then I'll talk more about it. As of now, I have just like made a post. And yeah, today evening, so we are releasing a system design by Anjali Seals. He's from Microsoft, basically. So you can, all of you can enjoy it. It will be freely available to all of us. So there are like 200 plus lectures that she has recorded. So I think we are releasing 8 module, not all. So 58 lectures. So some of the lecture we have combined together, collapse it into a single video, and then we are like releasing it. So even system design you all will be able to see, and many more things to come. So we are even working on the DSA. We are even working on the FANG preparation for our DSA, multiple things. We are even working on a web development as of now. So yeah, in March month we have a lot of release. So with that, guys, thank you so much everyone. Take care, and see you tomorrow. Thank you everyone.